Hello and welcome to another video. In this video, we are going to discuss a deep learning project, and this is a really kind of like beginner friendly project which you can develop if you are kind of like building your portfolio or just starting out in deep learning. So this is really an interesting project. So what we are going to do in this project, we are going to develop a deep learning model which will kind of like help us identify the digits, and we are going to achieve more than 99% of accuracy. Okay, so I'm not going to type all the codes, I'm just going to discuss the codes. Okay, so I have already solved this for you. I'm not going to type this code because kind of like it will be really time consuming, because training a model and everything takes a lot of time, so I'm not going to do everything, right? So just try to understand, go through this video step by step, do not skip anything, otherwise it's really fruitless, you won't be able to understand anything. So if you are like just starting out with deep learning, and if you want to build your first project, then this video is the best for you. Okay, so I'll guide you everything, and I'll show you how you can solve this problem and get really good understanding of convolutional neural network. Okay, so let's get started. And if you are new to this channel, please make sure to subscribe to this channel, and I'll be posting more such videos and discussing more such projects. Okay, so let's start. So to get started with this project, first of all, you need to have access to a computer. Okay, obviously, which you have, I guess. If you do not have, please visit Kaggle or Google Cloud, but you need this data set as well, right? So this is something you can get anywhere on the internet. You can even search for MNIST dataset. So this dataset is called MNIST, and you can search on Google, you will get this dataset. If you are working locally, you can download it and start working. But if you are working on Kaggle or somewhere else, please upload your data and start working. Okay, so first of all, you need to have these things. You need to have NumPy, Pandas, Matplotlib, PyPlot, and TensorFlow, and then Keras comes with it. So if you are not familiar with these concepts, what is NumPy, what is Pandas, what is Matplotlib or TensorFlow, if you need a refresher, please visit my website where I have created tutorials on this, and you will get a few notebooks where I have discussed these concepts in detail. Okay, so the data set that I have in this MNIST dataset. So currently I have this dataset in .csv format. So I do not have the images, I have the flattened version of this dataset. So all the pixel values are kind of like flattened here. So as you can see, this is kind of like in this tabular format, right? So since we'll be working with convolutional neural networks, so what we are going to do, we are going to convert these flattened version to the actual image. Okay, so we are going to convert these to the arrays, and then we'll start working, right? So the first step is to convert it back to the arrays. But notice that we also have label in our data set. So this label is nothing but this label is going to be used for the prediction purpose, so classification purpose. So which class particular image belongs to. So we have different classes, and we are going to classify images, which image belongs to what. So what this image is, right? So first of all, you can use this df simply means data frame. So you can use pandas read csv, and you'll use this code, you'll get this whole thing. Okay, so this is something I think everyone is familiar with, if you know pandas, right? Now what we are going to do, in order to convert this image, we first have to take out this label part. So we just need the features, all the images features means all the these pixel values, and we are going to extract this label part. Label will be separately, okay, and this pixel part will be what we are going to use for the image purpose, right? So we are going to use these features to convert to the image. So I have taken out these features, right? The label column is gone. Now here we can have list labels. Now notice, like, we have total 785 columns, right? So when we'll extract this label part, we'll have 784 columns right here, notice, and we have 42,000 rows. Okay. And then we have this label, and you can also like do some analysis based on your requirements. So you can do figure out what is the shape of the data. So the shape of the data is 42,784, and here we have labels 42,000, right? Now what we are going to do, we are going to convert this to the image array, and this is how you can do that. So you can simply like use this features.ilog, and this value.reshape into 28. So we are going to create this, and we'll have this whole array. Okay, this array of the images, right? And then what we are going to do, since we'll be working with convolutional neural network, and because I'm using TensorFlow, I'm going to make it TensorFlow compatible by using this approach. We are going to reshape into TensorFlow compatible shape, the way TensorFlow expect the data to be. So I'm going to use this 28 to 28, and this one is for the channel part, -1 is for the automatic detection of the number of rows, and this is how kind of like you can do that. So if you're not familiar with this particular method, just Google it. Okay, so you do not have to remember everything. Just notice here what we are doing is we are simply first converting the CSV to the image, then we are making the image kind of like TensorFlow compatible, the shape of the image, right? And then what we can do, since this is not kind of like a total like some typical traditional machine learning task, since it's a classification task, we do not need to do much data processing, because those things are kind of like not required here in our case, right? So we are simply going to turn to prepare our data for the model, and we are not going to do a lot of analysis on that. You can do that depending on the task, but right now here we are not going to do that. So once we have the images, what we are going to do, we are going to use that to divide, like create like test set, validation set, and training set. So in my case, I have used this sklearn model selection train test split. Okay, and I have created this xtrain x test, ytrain y test, means like I have created two sets. So that is training set and the test set. So I have not created a validation set separately, just because I just wanted to use that to the evaluate model, and because Kaggle has a separate set for the prediction part, so that's why I did not use a validation set. But it's a really good practice to kind of like use your own validation set, right? So whenever you are creating this xtrain x test, try to kind of like divide them into 3 parts, so that you can have a validation set, and based on the validation set you can optimize your model performance, and then you can use your x test to finally kind of like see what your model is actually doing, right? And then you can use the external data for the inference part. So whatever finally you are going to do that in the real world. But here I am simply going with this xtrain and x test for the sake of simplicity. I'm not going to create a separate another set, right? And I'm going to use this x test for the validation part as well. Now here I have simply plotted a few images just for the sake of understanding how my data looks like. And here you can use this approach, and the most important thing here is ax.imshow. Okay, so this method allows you to plot images, and these are just for the sake of beauty, and that's not important. But if you're not familiar, you can use this ax.imshow method, and even you can Google it in the documentation, and you will see that this is how you can plot images. Okay, so here I have plotted images, and this is how our data look like, kind of this whole thing, 6 5 3 4 7 8. So what we are going to do, we are going to teach our model how to identify these digits, right? So our model should be able to identify this as 6, and it should be able to identify this as 5, this as 3, this as 4, this as 7, this as 8, this as 6, so this 7 0 9 9 7, so whatever the digit is. Okay, and what we are going to do, we are going to make our model so confident that it is correct in 99% of the cases. So we are going to cross the accuracy of 99%, and we are going to see how we are going to do that. Okay, so this is going to be really interesting, because if you are like building your first deep learning CNN based model, then you will definitely be like happy to see that your model is doing well, right? Notice this looks like 6, but it is actually 5. So even for human beings, it can be a little bit challenging, right? Okay, so first of all, before we do that, so here notice in train test split we are using images, and then we are using labels. So the labels will be used for this y train and y test, images will be used for the x train and x test. Okay, so that is something you should know. And then what we are going to do, we are going to convert images to tensors. So here I forgot to write okay, so here you can use this tf.convert to tensor method to convert the data into tensors, because you will be using TensorFlow, so we need that tensors, right? So what you can do, you can use this method convert to tensor, then here you can use xtrain, and d type is tf.float32, right? So the convention is to use tf.float32, but depending on the kind of problem you are working on, you can use even higher precision. So if you're using tf.float64, it is going to use like more precision. Okay, but that also comes with kind of computational cost. So you want to stick to the tf.float32 if you are a beginner. You do not want to get involved with tf.64 or anything as such. But depending on the kind of problem you are working with, you have to identify the level of precision you want and everything. So that's something you won't be using, but for most of the cases tf.float32 is the best. Okay, and then again you have to convert all the labels to the tensors, but notice here I used this tf.float32 for the labels as well, but for the label part please use int32. I kind of skipped this. I was copy pasting this thing just to change this y train, and I forgot that I should be int32, but train will not give you any error, you will get the same output. But still this is something you should keep in mind, use int32. Okay, so yeah, label should be in integer. So another way of creating this label part is to use one hot encoding, right? But for the sake of simplicity, I simply used this integer part. The only thing that will differ is the kind of loss function we'll be using later on. Okay, so when you are using this integer, you have to use a different loss function, but when you're using one hot encoding, you will be using a different loss function. Okay, so this is the difference, right? So this is something I hope is clear until now. Let me revise. So first of all, we had our data in CSV format, and then what we did, we converted the data, we took out the label part, we took out the features, we used the features to get the image array. And once we have all the images in 28 into 28 format, so all the typical image format, and then what we did, we used those images and converted them into tensors. First of all, we divided into training and validation set, and then what we did, we made it compatible with the TensorFlow by converting into tensors and everything for the further calculation part. Okay, so now until now here we have prepared our data, but just for the sake of efficiency purpose, what we are going to do, we are going to use this tf.data.dataset API, which is provided by TensorFlow. So what this does is, this API helps you make your data pre-processing part really efficient when you are having when you have big data set. So whenever you have big data sets, it's a good practice to use this API, because it's really efficient. So your entire pre-processing part will become efficient, and whenever your data does not fit completely into the memory, this becomes really efficient. So you should read about it on your own, but just try to note that it's a good practice to learn these things in advance. This is not an important step. You can even skip this part but it's a really good practice to use this. Okay, so you can use tf.dataset from tensor slices, and once you have that, you'll get this train dataset and test dataset. So it has a particular format, right? And this does not mean you will be getting xtrn or ytrn. So what we are doing here is we are using xtrn tensors, ytrn tensors. That means it's kind of batching everything in the background, so images and labels. Okay, it's kind of creating them and putting them in a different manner within it, right? And so I'll show you what that means. Okay, so here just note that one important step that we should not skip is normalizing the images. So all the pixel values that we had, we had to normalize everything. Okay, so we'll be dividing that by 255.0. Okay, so why we divide by 255? Because we have 8-bit images, so 8-bit images have kind of values between 0 to 255, so we divide that by just 255 to normalize the values. And the reason behind this normalization is just to make the training process kind of more stable. Our model can converge in a better manner, and also will most of these activations functions that we use ReLU in everything, so they have kind of values between 0 and 1, so they work really well. And also if you have worked on traditional machine learning problems, you must have seen normalizing the data kind of helps in the training, right? So let's say some values are really big, some are small, so the big value will kind of dominate the entire training process, right? So we do not want that. We want all the features to kind of contribute in a really kind of equivalent manner. So that's why we do that. We normalize all the pixel values just for the sake of training. Okay, and also there are other regions, but it's a good practice. So you're just try to read about it. There are other some people even argue that this is not an important step, but we don't need that, but yeah, we do that, right? So it's a common practice, and the reason I explained to you earlier is the reason why we do that. So just for the sake of training part. Now what we are going to do, we are going to use this normalizer function to our the data set we have created here. So the train data set using tf.data and dataset API. So we are going to map that to each value, and this is how we do that. So dot map normalizer, right? And once we have done that, what we are going to do, we are going to use another method called batch. So we are going to batch our data into different batches. So batches kind of batches have collections of data points, so we are going to batch that into 32, which is kind of recommended. And then we have we kind of shuffle the data. So shuffling kind of helps in introducing randomization, so that our model does not learn something that's already presenting the ordered data. So we do not want our model to make a prediction based on the way data is arranged in the original data. So we want to shuffle everything, right? And after that we have this prefetch. So what this prefetch does, so prefetch kind of is another method offered by TensorFlow. But prefetch kind of you can say, let's say your model is working with one bucket of data, and prefetch kind of prepares the another bucket for the model, right? So you can use this analogy to understand. Prefetch kind of prepares the data for the next round, you can say. And then here I told you that this train data set and test data set do not have that initial appearance, xtrn, tensor, ytrn, right? So if you want to access those things, you can use this image labels and train dataset, and you can use this dot take one. It will take one batch, and then you can print your label or images, and it will output everything. Okay, so I just output the label here, and as you can see here, it's in float format, right? But it should be in int, but still it works. Okay, so it's not an issue, but still I highly recommend that here you should be using int 32. So yeah, please keep this thing in mind, and try not to get confused here, because we'll be using different loss functions. That's why we're using the integer based labels. And if you're using one hot encoding, then the loss function will be changed. I'll tell you what exactly that will be. So yeah, I hope this is clear until now. If it's not clear, please go back and watch this video once again until now. And if it's still not clear, please ask the question. Okay. So once our data is prepared, what we are going to do, we are going to start building our models, and we are going to like see which model is best, and then once we have like our final model ready, we'll use that to make prediction. Okay. So in this project we are only going to use convolutional neural network, but there are other like algorithms as well to identify images, but this convolutional neural network is the like best for the images. And if you are not familiar with how this convolutional neural network works, then I would recommend to visit my website, this neuralemy.com, and just click on this get started menu there. And once you go there, let me kind of show you. So on the website, go to the get started menu, and there you will find this tutorial on convolutional neural network. Okay. So yeah, so this is this tutorial on convolutional neural network. So here it shows 60% off or whatever, but right now everything is free of cost on websites, right? Except for the support, everything is free. And in this tutorial, what you can do, you can learn everything from scratch. So all the concepts related to convolutional neural network, how camera works, right from the very beginning, I have explained almost everything in depth. Okay, so you should definitely visit this tutorial, and this tutorial will give you a really solid understanding of convolutional neural network. And kind of I have developed this tutorial after thorough research, and you will learn a lot of things. Okay, so please visit this tutorial, I highly recommend. And you have lot of things in this tutorial, everything you need. Okay, so yeah, please visit this if you are not familiar with convolutional neural network. Otherwise we can follow with our tutorial. So let's move forward and let's start building our model. So what I have done in this, I have used a very kind of simple architecture here first. So in this architecture, what I have done, I have used a input layer, okay, which accepts input of the shape this 28 in 28. And then I have used a convolutional neural network with filters of 64, kernel size of 3, activation value, and padding same. So filter size is something you should experiment with and just try to keep it consistent. So mainly use a value which is divisible by 4, so that works well. And kernel size of 3. And then I have used this activation value, which is the something you should go for. It works well. And then padding same, because you do not want max pooling layer to reduce your feature maps to kind of a very small value. So you want to keep up feature maps down the layers, right? So that's why I'm using this padding same, because even if let's say filter does not fit entirely on the this feature map, it will add padding so that you can get some value down the line, right? So after that, I've used a max pooling layer, and then you have another convolutional neural network, and then max pooling layer again, then you have another convolutional neural network, then max pooling layer. And after that, what you're going to do, you're going to flatten for the sake of prediction purpose, like classification purpose. And then after that, I have used a dropout for the because I'll be using ANN after that, so I'll be using dense network. So I've used this dropout of 0.2. so this dropout value is something you should also experiment with. So this is kind of like hyperparameter, you can tune it depending on your task. So usually many people go for 0.4, 0.35, 4, 5. So like you can use values within this range and just try to see how it works. So this is simply kind of like it disconnects that many percentage of neurons. Okay, so once you have that, you have this keras.layer.ins, and we are using softmax because we are obviously classifying 10 classes. So we're going to use this softmax, and then we are going to build this model. So here notice that I'm not using sequential API, right? I'm using functional API, and functional API is kind of very flexible when it comes to building your models. So you can develop different kind of architectures. That's why I'm using this functional API, and I love this approach because this is kind of like really looks good, and it provides a lot of flexibility. So I use this approach. Okay, you can, if you are comfortable with a sequential, go with that, otherwise that's not an issue. Now here you are using this input passing to this layer, then here you are using this x value. So here just notice this x is this x, this x is this x. So whatever value here comes, that goes here, then here, right? So this is something, if you're not familiar, please practice this one. Once we have that, you can check your model summary and see how our model progresses layer by layer. So in the initial layer we have this 28, 28, 1, and this none is just for the batch size. So this is none is automatically detected depending on the batch. So this is something like 28, 21, and then after that we have this convolutional neural network. Then we are doing max pooling. Then after max pooling, as you can see, the shape of the feature map is this, and then all the layers here, you can see the shapes. Then we have flattened. Okay, and then after that we have these 10 all the outputs of the classes, number of classes that we have. Okay, so the total parameter is 80,266. So this is really a small number of parameters as for the deep learning models, because if you see the transformers and everything, they have kind of like in billions, trillions. So this is nothing. Okay, and those models can easily identify what the digit is. Okay, so this is just a small model, but still it's really it's going to, this model is still able to kind of achieve a good degree of accuracy. So we are going to see that. So now what we are going to do, once we have prepared our model, we are going to compile the model, and here notice that I am using sparse categorical cross entropy loss. Okay, and I'm using Adam optimizer, metrics is accuracy. So sparse categorical cross entropy, why? It's because I told you earlier that I'm using this int, right? So whenever you are using integer labels, here I'm just simply using integer labels, because here it's float, but just please use int. So I'm using integer labels. Okay, so whenever you are using integer label, you are going to go with sparse categorical cross entropy, otherwise you're going to use simple categorical cross entropy in case of one hot encoded labels. Okay, so this is something you should keep in mind. Now for the model.fit part, we are simply going to pass the train dataset, validation data as the test dataset, and see, we are not using this xtrain ytrain. Why? It's because we are using tf.data.dataset API, so we are not going to use that. Model.fit accepts all those things, but whenever you are using this tf.dataset, you should pass in this manner: train dataset, validation dataset. And for the epochs part, we are going to use the 10 epochs, and for the 10 epochs we are going to train our model. Okay, and once you have train the model, just notice that here our accuracy is 0.83 in the training part, validation accuracy is 0.98, and notice how our validation accuracy has kind of here it's kind of best, you can say, 9912, but I did not use any callbacks at this moment. So this is going to use this final value. Okay, so once we have this final value, we can evaluate that on the test dataset. And since we are using test dataset for both the validation and this test part, we'll get the same value as this one. So this 9 and this here, right? So this is the accuracy that we are getting on our test data set. Okay, now the thing is, we can also increase the number of epochs. So here you can increase the number of epochs and see what is the how model performs. And you can also kind of like implement callbacks and other things that Kera has provided, but for the sake of simplicity I was not doing that. Okay, for this particular tutorial I just wanted to increase the level of difficulty one by one. So just try to experiment with that. But still notice that we have we have managed to kind of like get an accuracy of 99%, right, just by using this particular approach. So this is a really simple architecture, and using this architecture we have managed to even score like 99% of the accuracy. So notice how powerful convolutional neural networks are just by this total number of params, which is 80,266. We have able to achieve kind of like this much accuracy. Okay, and the data points we had was around 40,000, 44,000. So just note that this is really great. Now let's move on to the next architecture, and we are going to try to improve upon this. We are going to increase the accuracy level, and we are going to see how kind of like we can make a model even better. Okay, so in this kind of like approach, what I have done, so first of all I'll show you the model architecture, and then I'll get back to the explaining part. So notice this is kind of like not beginner friendly thing, but let me show you. So what I've done, I have used two layers. Okay, so you can say like two layers in the parallel. So two model architectures are there, so one on the left side, one on the right side. Okay, and we have this model architecture on this end, on the left end, and then we have this kind of on the right end. Okay, and what we are going to do, we are going to kind of combine them together, mix them together, and then we are going to use flatten layer, then dropout, and then dense layer. Okay, so we are kind of like what we are doing, we are simply giving model two different perspectives to see the data, and from the two different perspectives we are kind of like giving model a better understanding, just for the sake of like improvement part. And this is kind of something that's inspired from Siamese network. So it's in Siamese network, what we do, we kind of share the weights, but right now we are not sharing the weights. We are simply keeping two architectures in parallel, and then we are combining them. Okay, so it's called dual input multi input architecture in TensorFlow, and you can use this in various problems. And if you have kind of little bit experienced with the machine learning or convolutional neural networks, then you will be using these things a lot. Okay, so you can do this, follow this approach, and you will get like better results. So it's kind of like giving model perspective from different angles, you can say in simple words. So for this architecture, what we are doing, we have this left part, and then we have this right part. Okay, so let's understand the left part. So left inputs, we are going to do the same thing, layers, input layer, then we have like left input, and then for the this convolution part, what we are going to do, we are going to this convolution 2D. Okay, and in the initial filter we have 32 filters, and we have this dropout layer. We have also used dropout layer. Okay, and we have this max pooling 2D. So why we are using these dropouts and everything? So dropouts is something you can avoid if you want. I'm using this simply because there are just too many convolutions, and model architecture was kind of like there were too many you can say neurons. That's why I was using it. And this will give you a better performance if you try it out. It's all about experiment. Okay, and whatever value you are using, you just try to experiment it on your own. Okay, you can keep experimenting with the model architecture, and you will get different output, different values. If you are satisfied with this value, go ahead with that. Otherwise you can keep on building your models. That is something you should keep in mind, that there is no sure shot of how to achieve great accuracy. It's simply just based on the popular architectures. Just try to keep yourself familiar with different architectures, then you will automatically get in mind that how things work and how to utilize those architectures in your own problems. Okay, so here what we are doing, the idea here is initially we are using 32 filters, then dropout, and then max pooling layer. And after that, what we are going to do, we are going to simply double the filter size. So in the next part, so this, and then again this, but next time the filter size will be 64, and then again in the next size it will be 128. Okay, so we are going to do the same thing for the left part and same for the right part. Okay, once we have done that, what we are going to do, we are going to use this concatenation layers. We are going to combine them, x and y. X is this and y is for the right side, and then we are going to flatten everything, and then we are going to use another dropout, and then we are going to use the final dense layer just for the classification part, and then we are going to build the model in this way, keras.model. So we are going to pass them in the list, left inputs, right inputs. Okay, and then we are going to use this outputs, which is nothing but the combined part. Okay, x and y. So this is something, this is how you can build multi-inputs model. Okay, and after that I have used this kera.utils.plot model just to show you. So here notice, like input is this input layer 28 28 1, and then you have conv2d. Okay, so in conv2d and then you have dropout, max pooling. So here notice, like we are using this 32, and then our filter size and everything is kind of increasing after every this is again conv2d, dropout, max pooling 68 and 64, sorry, and then again here we have 128 128. Okay, so we are repeating these three things again and again. Okay, each time we are simply doubling the filter size. So this is kind of model architecture that you can follow. I have also taken inspiration from based on my practice. Okay, so this is not something that came to my mind out of nowhere. Obviously I have taken inspiration from other works because I have solved other problems, so I have an idea of how to do that. So you can simply implement this, and again in this part, once again I have like conv2d, dropout, max pooling with 32 filters, and then we have conv2d, dropout, max pooling, then again conv2d, dropout, and max pooling. Okay, and then what we have done, we have combined them together and we have flattened them, and then after that we have used the dropout, and then we have used this dense. Okay, and finally we are getting this. So whenever you are building convolutional neural network, you will most of the time you will get shape errors. Okay, so what happens sometimes, shape compatibility issue is there. So just try to keep in mind that whenever you are building model, you should be familiar with what shape you are passing down each layer, right? So if your shapes are not compatible, then there will be issues. So just try to visualize your shapes and try to see how your shapes are passing down. So at the end, if you are this if you're not getting this particular thing, if you're, let's say if you're building something, if you have classes which are 50 classes, 60 classes, so the output should be in this format. Okay, so try to analyze your each layer. Okay, plot your model layer by layer, okay, and then start building. Otherwise, if you're getting any shape compatibility issue, you will get some errors, and I think that is the most frustrating part whenever you are getting started and you start getting shape errors and everything. So here also you can use this model 2.summary, this summary method, and you will get everything. Okay, but I think whenever you have complex model, it's better to use this utils.plot approach, because that gives kind of a visualization of your model architecture. So this is something you can use, and model.summary is fine for smaller ones, but this does not make sense. But here notice total params is now we have kind of doubled, more than double the total number of parameters of our model. So right now we have 208394. So here this is this lot. Okay, now what we are going to do for the dual input part, we are going to kind of slightly modify the input, because our input is in a different manner, so the model accepts like input in a different manner. So here this input is in different manner, left input, right input. So what we are going to do, we are going to refactor our initial pre-processing part in this manner, in different manner. So this this normalization function that we were using earlier, so we are going to simply change this to kind of like add a tuple of like this image and image, and then we are going to like pass this to the training data set, map it to the training data set. And initially we had input divided by 255.0, but here we have like two inputs because we have inputs from both end, right? So that's why. So you need to have slight modification when you are building dual multiple input based architecture. So you have to optimize pre-process your entire data set according to that. So again, so this can be frustrating, but obviously you have to prepare your data once again according to that rule, right? Now again we are using this batch, shuffle and prefetch. Now here what I'm going to do, I'm not going to like here what I did earlier, I did not use any callbacks, so the model automatically took the final value, right? But here what I'm going to do, I'm going to train it for more epochs, and I'm going to save the best model weight. So whenever the model is at the best, I'm going to use that. Okay, so what I'm going to do, I'm going to use this Keras callback. It's called middle checkpoints. So what you can do, you can use this callback within the model. So whenever your model is at the best performance, Kera will automatically save the best performance, and that will be the best model until the next best model appears. So whenever the next model, best model appears, whenever the performance improves, at that point the model will be saved again. This is repeated until the end of the training, and the final model will be the best one. Okay, so we'll see. Again, here I'm using this sparse categorical cross entropy because I'm using integer based label, Adam optimizer, matrix accuracy, and here I'm using this history for the sake of plotting purpose. That I did not do in the previous one, but here I'm using history. And then you have the same named new train dataset, validation dataset, epochs. I've increased the number of epochs because I'm trying to train the model and find out when it is at the best. And here I'm passing another this value, callbacks, checkpoint callbacks here that I created, model checkpoint. And what this is going to do, this is going to save the model at the best value. Okay, so here initially it will save the model, saving model to best. Okay, so this is the model name I created. So at this point it has saved the model, and then whenever the validation loss improved, it saves the model and it discards the previous value. Okay, so it goes on until you have this training process ends. So here as you can see, the model did not improve. Okay, model improved from this to this. Okay, so you can say this is the final model. At the epoch 15 we will have the final model. Okay, and this will be the final model that we'll be using for the prediction. So these things are not saved because the validation loss did not improve. Okay, now whenever you are making the evaluation or prediction part, you are going to use that saved model. So we are not going to use this model to dot evaluate. We are going to load the model using this dot keras dot models dot load model, and we are going to make the prediction using that, or whatever you want to do. So here notice that our accuracy has improved a lot. So here we have 99.33. okay, so this is really a good improvement over this 99.07 we had earlier. So 99.07 is here, and this is a really good improvement. Okay, this is 99.33. Now what we can do using the history, this dictionary that we had here. So history here, so TensorFlow lets you access this history, And using this dictionary, this is a dictionary, and using this we can plot, like plot our graph, and we can analyze where the model training, how the model performed during the operation. So as you can see, during epochs, each epoch, how our loss improved or decreased, as you can see, the loss kind of here is at the lowest here, right? So this is the lowest value, and this is the validation loss. So we are focusing on validation loss. And if you notice, in this case also, the accuracy at that point should increase. So accuracy at this point should be at the highest. Okay, so this is how you can kind of analyze. And if you want to do further analysis, feel free to do that, but I just wanted to show this. In the previous model I did not plot these things because I just wanted to keep the explanation simple, but here you can see I have this accuracy here in this plot, and this is something you can use. Okay, and after that, what I'm going to do, I'm going to make the final prediction using this predict method, and I'm going to use this new test data set that we created using the final model. We are not using model 2. And the predictions here, you will be getting the probability. So this is something like model gives you a 2D array of all the images. Okay, and it tells you that the image 1, it has the probability this much for belonging to a particular certain class, and it expresses the level of confidence it has in, it has for this image can be 1 or this can be 2, but these are the probability, right? So the model does not give you a specific output, so it gives you multiple probabilities. Okay, and whatever the probability that is at the max will be the final value. We'll be choosing that as the final value. We'll take that as the highest confidence. Okay, and whatever the index of that will be the label. Okay, so if you want the predicted classes, you can simply use this to extract the index that is at the highest, where the values is at the highest. Okay. Hey guys, so if you're watching this video, please ignore the voices in the background, because right now something is going on in the neighborhood, so please avoid the noise. And this audio recorder is not able to cancel the background noise, so just ignore that and focus on what I'm telling. So the idea here was to first predict, get the probabilities. Once you have the probabilities, what you can do, you can figure out which index has the highest probability, and you can take that index and it will give you the label of this particular prediction. So whatever prediction that is there, so it will give you the label. Okay, and now what you can do, if you want to do we have done with the training part. Now let me tell you the reason why our model performance has increased. Okay, so you should be able to understand why your model performance has increased. Okay, so let me tell you something I did not explain earlier. So the reason being is that this kind of where is the model? Yeah, so the reason is that we are kind of in the initial layers we're using 32 filters, but then we are doubling the filter size, right? So first of all, I told you that we are giving two perspectives from left and right hand side, and also we are doubling the kernel. So these filters, so these filters are kind of the initial filters are learning the small details, the smaller details, and then these bigger pictures are bigger filters are kind of learning all the other kind of complex features. So it's kind of you are simply allowing your model to learn better features as it processes from one layer to another. So this is the reason why your model performance has improved slightly. Okay, so so the reason being is that different filters are getting different abilities. So they are focusing on different areas of the image, and that's why it's kind of working out really well. So yeah, this is the kind of this is how you can build your model and get this accuracy of 99.33%. But let me tell you, there are like other ways of improving the performance. So first of all, initially we had like 40,000 or around 40,000 images, but I think that is kind of like from the standard of deep learning, it's really a small number, small size data set. So if you want to kind of like improve the performance further, you should do some data augmentation or add some more data sample to it. So if you do data augmentation, TensorFlow allows you to do that. So I did not do that here, okay, for the sake of simplicity, but you can further like do some data augmentation. And using the data augmentation, what you can do, you can introduce more varieties to the data set we have, and our model will be able to kind of like get better at that. So if you notice, like many people do that when they have smaller samples. Also, if you have like ability to gather more data, you can figure that out on your own. Okay, so this is like how you can improve your model prediction further. Also, you can try out like different architectures, like ResNet, DenseNet will definitely these are like these are few model architectures that you can try out if you want. And obviously, like you need to increase the number of data samples that we have right now, because I believe 40,000 is not enough. Okay, and but still we have really a good model which has crossed like 99.33 percent. So this is really a good number. So if you are a beginner and if you're building this project for the first time, getting this particular value is a really good like good data, and good number. Okay, so this is really something you should try out. And if you want to implement other architectures, you can do that. And here I have, just for the sake of analysis part, what I have done, I have taken one batch, and one batch from this data set. Okay, and I have taken this batch, and I have made the prediction on the batch. Okay, so whenever you are doing the prediction for the batches, you will be passing the prediction like in that format. And this is something like you should be doing, because we have dual inputs. So that's why we are using batch images 00 batch image. Okay, and you can make the prediction and get the same thing that we did earlier. Right here, earlier we were doing it for all the images in the test data set, but here we are doing it for the batch, for the single batch. Now what we can do, we can try to plot them and see how accurately our model has predicted what all are true and what are all are false. So the batch for which I have predicted, it's kind of like everything is like all the true value is 3.0, the prediction is 3. So right, all are the same. So this 3.0 is coming here because of the mistake that I did earlier, but still it works well. Okay, so TensorFlow did not give me any error for using float 32, because it just works out behind the scene. Okay, so yeah, here as you can see that here we have like all these things that are correctly classified. Okay, so yeah, right, so this is how you can like analyze. And if you want to know how I did that, you can simply first plot the image, then you can use the true labels, and then you can use the predicted labels, and you can then set titles. Make sure that you made this axis off so that you do not see x and y axis. Then you can use this plot the plt.show, and you'll get these things. Okay, and also like if you want to make your final submission, you can like use this same approach. You have to make sure that you are pre-processing the data in the same way you have done it for the training purpose, otherwise you are not going to do that. Also, one important point you should keep in mind, that whenever you are making prediction and whenever you are preparing data on the final test set, you should not like shuffle the data. Shuffling is only for the training purpose. In the final prediction we are not shuffling here. So here using 32, but we are not shuffling it here, because we want to maintain the order just for the sake of just for the sake of submission part, and we do not want to lose consistency in the output. Okay, otherwise everything will appear like you made 0, like you will get 0. So this is something you do not want to do. And we have like, once we have pre-processed the data in the same way, that we are going to make the final prediction, and we are going to create this data frame and we'll submit that the way Kaggle expects it to. Okay, and if you make this submission, you will definitely get around 500. So this is something, this 500 rank. Okay, and if you implement all the suggestions I made, like data augmentation, trying out different architectures, and even like maybe experimenting on your own, so these are things like mainly data augmentation is needed here, so you should do that and you will be able to achieve even better. Okay, also like there are other approaches that exist if you want to go beyond like this accuracy level. So there are like models, specific models just for this task, that are kind of like going to give you 99.99% level of accuracy, but those models do not generalize well to other tasks. So like you cannot, like you can use typical algorithms for that, but those weights won't be useful if you want to use weights for the downstream tasks. So you can use that, you can improve the model, but yeah, for the time being, stick to the basics. Try to implement your sequential layers, and then move to functional API, and try to build on try to experiment with smaller, less complex models, and then move on to the more complex architectures. Otherwise things will be a bit confusing at first, but once you get an idea of how to build the model, you will be able to implement your own architecture. So initially you can simply if you are just building for the first time, you can simply like let's say use two layers, right? These two layers, and then you add another layer, maybe start with different number of kernels, 32 and 128, whatever you want, and see how it works, and then try to add your layers on your own. So you do not have to start with a something complex or something like that. You simply have to experiment. Okay, and once you have experimented, simply just try to improve further. So this is the approach you can follow. And yeah, that's it for this. And if you have like if you want to know how convolutional neural network works and everything, I showed you the link. Please visit my website. There I have discussed everything in the depth, and also I have talked about how TensorFlow and everything works, so you will see all the tutorials. So for the time being, that's it for this tutorial. I hope this was kind of helpful. I did not code everything, otherwise things would be much more clear, but still I hope you'll be able to follow along and you can use it. So yeah, since some disturbance is going on in the background, I'm going to finish this video at this moment, but I hope this video was helpful. If it was, please make sure to subscribe to this channel, because I'll be posting more such ML projects related videos, and I'll be discussing such more projects in the future. So yeah, thanks for watching, and have a nice day.